Okay, so cross product is slightly different than dot product. So cross product is get something different. I don't know if you can read the sentence, but
Should we write that?
no, I don't think you need to write it, but maybe you can write down why you would need to use the cross product. Thank you. So the cross product is a way for you to analyze geometric shapes. So it gives you the ability to find areas of vectors. You guys aren't listening.
Sorry.
Areas between vectors. Okay, so for example, if I have two vectors, I can use the cross product to find an area. Okay, and I'll go into more detail, but it's actually pretty slick. Okay, so I'm going to scroll down somewhere. Oh, you should write this down. Maybe not yet. Hold on, we'll come back to that. I feel like this kind of got written out of order. Okay, this is what I wrote down and what I think you should write down.
Oh.
I even wrote down my definition for you guys for this, so that it has X, Y's, and Z's in it instead of other things. Okay, so check this out, you guys. This is really interesting, and this is kind of an intro, a very small intro into matrices. Okay, so do you guys know what a matrix is?
Yeah, I always get them wrong on my ACT test.
Okay, so then you don't know what a matrix is.
Oh, yeah, well, I mean, I know of them.
Oh, there we go. Okay, so this right here, this matrix right there, do you guys know which one piece I'm talking about? This is a matrix right there. Okay, so a matrix is basically a way to organize data. Okay, so it's composed of columns and rows. Okay, so this particular matrix happens to be a 3x3 matrix. So 3 rows and 3 columns. Okay, so when we use the cross product, we're going to use matrices and the idea of a determinant to figure out the resultant vector, which allows us to then find
ZUXV.
Yeah. Okay, so what? U times V. Yeah, the X. Cross, like it's multiplication. Nope, across. It's different than the dot product. Remember how the dot product was multiply X's and multiply Y's and then add them? Cross product has the multiplication symbol. Okay, so that's how you know which one is different. Okay, dot product is used to help you find angle between vectors, but cross product is going to help you find potential areas. Okay, so once you get to that, I want you to write down the 3x3 matrix. Once you get to the 3x3 matrix, you should write down the stuff that I have in blue.
What if
You can write down the other part, that's totally fine, and I can even show you how to type that into your calculator with using matrices, but it is easier to just do the algebra. It's faster.
So I should have this one written
And then the blue, yep. So once you have the red, just write equals the blue, because that's the way I want you to do it.
So Z dot or Z1 in the very first?
Oh, good question. That is a 1. I will rewrite that so that it is more obvious. Yeah. And one thing, make sure you notice, you guys, I'll tell you what, I'll be perfectly honest, I totally missed that minus sign right there the first time around. And I was like, why am I getting all of these wrong with the minus? And then I went back and looked at the definition, and I had written down a plus sign instead of a minus sign. So I'll let you know my mistake so you don't make that mistake.
I don't make mistakes.
Oh, good. All right, is everybody done? No?
Yep.
Okay, so before we do an example, I want you to start to see a pattern, because really all this is a pattern. It's actually kind of cool, and you start to realize why they call it cross product. Okay, mathematicians are not creative. They're very literal. Okay, so watch what happens. Okay, you have the definition in front of you, yes? That blue definition? Okay, so on the very first one, notice what happens here. Okay, so it starts with I, the very top letter in the matrix. Okay, and all they do is they take this little square first. You see that little square? Okay, and all they do is they go y1 times y2 minus y2 times z1. See what I'm like doing?
Cross
Multiplying, right? You've seen that before. And that's just the definition. Okay, on the second one you have a j. Okay, so the j involves the values that are not in the j row. Okay, so we do x1 times z2 minus x2 times z1. You see it?
No, wait, what? You do that over.
Okay, so
You always start top left.
So yeah, you always go straight across. So for the j, you use these two rows, the ones that are not in the j row.
Okay.
And you're going to multiply across. So you're going to go x1 times x2, or excuse me, what letter is that? Z. x1 times z2 minus x2 times z1. Okay, to get the k.
And then
What?
so you subtract the I1 from, or the J1 from the I1, then you add K. So why does it subtract?
Yes. Sometimes they say thank you for the rules. You want to know why. Okay, for the k, do you see which letters are used for the k? So not those ones, they use this one. So to get the k, you do x1 times y2 minus x2 times y1. You get it? Okay, so as long as you can recognize that pattern, it becomes pretty easy. Okay, so let's do a quick example. Okay, so write that down.
Alright, example.
Example number 1. Okay, so we have find u times v. And just so you know, v times u, what do you think about that? Do you think that you can switch the order of those?
Yeah.
Does it matter?
No.
We should try it and see.
I don't know. This is bigger like 2 times 1.
Do you think we should test it, or should we just assume?
We just
Just assume.
It's 2018.
Wait, why couldn't you?
Component rules. No, we cannot.
Because like 2 times 3.
Do you think all those patterns will work? Just because it's like, I don't know, we should test it. Okay, so the first thing that I'm going to do is I'm going to write u in component form, because perfectly honest, my brain just is a component form. It just works better that way for me. I'm pretty sure most of you probably don't need to do this, but I'm going to do it anyway. Okay, so to do the u times v, I'm going to start by writing my 3 by 3 matrix. So what goes in the top row? I, j, k. Perfect. Okay, now what goes in the second row?
I can tell you.
Mm-hmm.
2i.
Without the I, but there is a 2, yeah? 2, 2, 1, 1. It's just simply the u vector.
Okay.
See the u vector?
-4.
Yeah, so now the v vector goes on my third line, exactly.
Okay.
That makes sense?
Yeah.
Okay, and that's why it's listed I, J, K. So the I's go in row 1, J's go row 2, K's go row 3. It doesn't matter if you switch, well, that's where I was, oops. Okay, so we got I. Okay, what 2 numbers are we going to multiply first for the I? 1 and 1. So can we go ahead and say 1 times 1 makes 1, and then we're going to subtract what? 3 times 1 makes 3. Everybody with me? So we're cross multiplying. Okay, then I do minus the j's. So what 2 numbers am I going to multiply for the j? Because it's minus. You always subtract them. On the crosses, yep. Yeah, see? Subtract. Okay, what two numbers am I going to multiply first for the j? Good. 2 times 1, 2. And then minus, very good, minus -4 times 1 is going to be minus -4. So plus 4, good. Everybody with me?
And then we add.
Give me a shake if you're not with me. Okay, and then what did you say for k? So k's, you're using the row that's not in the k, the two columns that are not in the k row. So 2 times 3, do you see the 2 times 3?
Why are you not using 1 plus 1?
On the last one? You gotta multiply across. So 6 plus 4. Okay, ready? Let me show you. Okay, so to get the i's, we're using the I row, so we're going to multiply across. So 1 times 1 minus 1 times 3. Right? Determinant. These are determinants. That's how you find the determinant in the matrix. Okay, for the j row, okay, I'm going to do these two. So 2 times 1 minus -4 times 1. Okay. So 2 plus 4. Okay, for the k, we're going to use these two. So it's going to be 2 times 3. So 6 minus -4. Is everybody okay? Okay, so let's finish this off. We're just going to simplify and we're going to have a vector left over. What's 1 minus 3? So I'm going to put -2i because I like my variable pieces in the back. And then, yep, you do. You do. Plus 6j, or minus 6j, and then plus 10k. You can leave it there, or you can throw it into component form if you want to. I don't care which way you leave it. I would say if you give me standard form, I call it right. Component form, it's fine.
Is that what we're doing? Can we do a worksheet now?
Oh, well, almost.
It's gotta get harder.
Not a lot harder.
No, I disagree.
I do? Do you want to do one more example like that?
No.
No, let's do it harder.
Okay, wait. So, example 3 says,
Alright. That's straight.
find a vector perpendicular to u and v.
I have an idea.
So check it out. Hold on. Let me explain. So, finding the cross product actually finds the perpendicular vector.
Oh, okay, so we don't need to do it.
So, all you have to do is do the cross product, and that is going to be perpendicular.
Nothing changes.
So nothing changes, but now you understand that the cross product allows us to find a perpendicular vector. That makes sense? Sort of? Okay. So, perpendicular vector. Now check this out. This is where things become super awesome. In the vector world. Well, it's cool, I think. You can find the area that exists between two vectors. So for an area, okay, so a parallelogram. So let's say we had two vectors, okay, so let's say we had vector, I don't know, v, and vector u. Okay, so what happens is if we kind of create a parallelogram out of this, we are able to find its area. Okay, and all you have to do to find the area is do the magnitude of that perpendicular vector. Okay, so you need to write that down in your notes.
What?
And I'll do an example of that one. The area of the parallelogram created by the two vectors. That's a little symbol for a parallelogram. It does not look very nice. Let me try again. Parallelogram. Okay, because it's just the magnitude of the vector that we've just found in that last question. So, x squared plus y squared plus z squared, square rooted. And then also you need to know that, because they're going to ask you this on your worksheet, that the triangle is simply half of the area of the parallelogram. Isn't that fancy? I'll do an example. But it's just like what we've done in the past. So you take that vector that we found in that last question and just find the magnitude. So x squared plus y squared plus z squared square rooted. Okay, so let's do this one and then we'll call it good. I think you'll be good after this. Okay, so this question said, did I go too fast? Everybody wrote that down? Okay, yeah, good. Okay, so find the area of a triangle with vertices P, Q, and R. Okay, so first of all, what are they giving to us? They're giving us points, not vectors. So how are we going to create vectors from the given points? Okay, we did this in that last section, or maybe it was 2 sections ago. We're just going to find the vectors by doing the terminal minus initial. Remember that? Okay, so we can choose what vectors we want to do. Okay, I'm going to do a PQ vector, and then I'm going to do a PR vector. Okay, I want the points that we use to be the same, so if I pick P, I'm going to do PQ and PR. If I was going to pick Q, then I would do a QP and a QR. You see what I'm saying by that? You want that point to be the same on both vectors. Okay, so PQ, you ready? So I'm thinking terminal minus initial. Okay, so if I go from P to Q, which one is my initial point, which one is my terminal? Okay, P is initial, Q is terminal. Okay, so what am I going to subtract first? What? Okay, so we have 2. Do you guys see what I'm saying? So terminal, so the x value on Q, so 2 minus 1. So it's 2 minus 1. 1. Okay, then I'm going to subtract the y's. 1 minus negative 1. 1 minus negative 1. 2. And my third point, negative 1 minus 0. Everybody following where I'm getting these numbers? 1 minus 0. Okay, now I'm going to go from P to R. P to R. So now R is my terminal. So I have negative 1 minus 1. Negative 1 minus 1. Anybody? Negative 2. Good. Okay, then we have 1 minus negative 1. 1 minus negative 1. 2. Uh-oh. This is not supposed to be the hard part, guys. 2 minus 0. Good. Alright, so I have my 2 vectors. Okay, so now I'm going to do my cross product. So I'm going to multiply PQ times PR. Okay, so on my 3 by 3 matrix, what goes in the top row? Hold on, what goes on the very top? I, J, K. Then what's after that? 1, 2, negative 1, good. And then what goes in the bottom? Negative 2, 2, 2. Okay, you ready?
Yep.
Okay, here we go. So we have our I. I don't know why I like to put the I first, but I guess it should go last. Okay, what 2 numbers am I going to multiply first? 2 times 2 minus 2 times negative 1 plus 2. Then minus J. That makes 6. That's not. Minus a negative. Minus a negative. Plus 2. Plus, because it's minus a negative.
Yeah, 4 plus 2.
What? So it's like a 2 or a 6.
That's a 2.
Well, that is, the drawing is 2, but when you add it together, it's 6. Oh, okay. Alright, so what do we multiply for j? So we don't use our j row. We're going to multiply 1 times 2 minus negative 2 times negative 1 minus 2. Thank you. For my k, I do not use row k, so what two numbers are we going to multiply first? 1 times 2 and negative 2 times 2. So minus negative 4 makes plus 4. Alright, so we're going to get 6 i's. Ooh, what happened to my j? Oh, be careful, Sam. Be careful. Okay, so if I have a 0, do I write it? No. Okay, it's gone. In standard form, you would not write it. If it was component form, I would just put a 0 there. Okay, and then I can say plus 6k. Okay, so that is my cross product, but if I'm trying to find the area of a triangle, how do I find the area of a triangle? 1/2. Okay, and then we have to do the magnitude of this piece that we just found. Okay, so to do magnitude, so I'll do 1/2. So it's just x squared plus y squared plus z squared. So what's my x? 6. What's my y? 0. Good. And my z? 6. So I end up with 36 plus 36, and 36 plus 36 is 72. Ooh, can I break 72? What perfect square number multiplies to 72? 9? Wait, bigger than that. 36. 36 times 2. So 36 times 2 square root of 36 is 6. And then 1/2 of 6 is 3. So this breaks down into 3 square roots of 2. And that would be the amount of area that exists between those points. Which is pretty cool. I mean, we could have totally gone about that geometrically, but instead we used matrices and vectors. Okay, I got one last thing for you, and I think I'm gonna give this to you as a definition, I think. I don't know, we'll see what you guys think.
Hey, Miss Nolte, I just got this.
So you ready for a new shape? This is a cool word. This is the first time I've seen this. Huh?
I got a quick side.
Oh, good.
Did you ever teach Jonathan Eastwood?
No.
His name's Summer.
Yeah, no.
Or Autumn.
No. You're wrong.
Let me look.
Come on, keep going here. Let's focus. No, you're wrong. Okay, so
I looked it up this week.
volume. We can also find a volume of a parallelepiped. Parallelepiped. I've never heard of this word before. Okay, so the idea of this would be like, okay, like you would have 3 vectors. You guys, hey, Garrett, put it down for 5 minutes. Let me finish. Let me finish. Okay, I have 3 vectors. See my hand right here? This is 3 vectors. I got vector u, vector v, vector w. Okay, so I have a 3-dimensional space. So basically what happens is if I turn this around and kind of connect, let's see if I can connect that. No, I can't do it very good. But anyways, if you, that didn't seem right though. Anyways, that's not right. But it should create more of a parallel, like a 3-dimensional parallelogram. Right. Okay, yeah, which creates a volume. Ooh, there you go. Except for, yeah, oh, that is how I had it. Okay, yeah, I did it. Okay, so it creates a volume. So write down this matrix. Okay, and the only thing that is different about the 3 by 3 matrix we did before is that the top row is going to be, this top row is your U, right? This middle row is your V, and the bottom row is your W. Okay, so when you do that exact, I don't know, I wrote that weird. No IJK. So instead, when we do the matrix and you write down that blue rule that I wrote before, remember that? The blue rule that I wrote from before? Okay, you're going to lead it with numbers instead of I, J's, and K's. Okay, so the first number will be whatever exists on that.
So.
Okay, so when you, okay, we'll do an example.
1 second.
I've got too many weird looks right there. No, you have to have 3 vectors because it creates a volume. 2D is area, 3D is 3 vectors. Yeah. Oh, here we go. Can I just show you this example? Yeah, let's do that. That's perfect. Okay, so here is the example. Okay, let me explain it. I'm going to bring this up so I can kind of record my ideas. Okay, so they give us this vector. So vector U is 1, 2, negative 1. Where does the 1, 2, negative 1 go?
Top.
Okay, it goes right into that top row. Okay, 1, 2, negative 1. Okay, vector V is negative 2, 0, 3. See how they try to trick you right there? They missed a term. Okay, so negative 2, 0, 3. Okay, for the W, which term is missing? I, so the I is 0. 0, 7, negative 4. 0,
So
negative 7, 4.
the same thing, but
Yeah.
No, oh, that's.
Yeah, that's why I was
So
thinking
when
you
they,
didn't
when
need
they
an
give you
example.
3 vectors, and you just group it into 3.
Yeah,
Oh, okay.
and that gives you a volume, which is pretty cool, right?
Yeah.
Okay, so that I that we initially put here is now going to be replaced with a single number. Okay, so when we get that number, we'll multiply that by that quantity that we got. So this is written in vector form. So like when we did it, we would have, we can write this, 1 times 0 minus 21. Yep.
Well, that second box.
The second one? The second box is just the numbers that you use. So if this is the 2 row, you're using negative 2 and 0 and 3 and 4. You see that? Right. Right. So yeah, I mean you still do it the same. I didn't really show you the vector format of it. So if I was going to do the second one, I'd go negative 2 times negative 4. That'd be 8. And then 0 times 3. So that's 0. And then the last one, my negative 1 would go on the top. So negative 1. So I don't use this row, so it's going to go negative 14 minus 0. Okay, so the thing that you need to understand is on that first term we get what? Negative 21. Second term we get 16. And then last we get plus 14, right? You guys follow that? Okay. So 21 minus 16 is negative 37 plus 14. Negative, no, 23. Oh, 23. Wait. Oh, absolute value. So I did get negative 23, but do you guys see how you then turn it positive? Because it's absolute value. Right? Okay. So 23, and that is just your volume, so it would be units cubed. That make sense?
Yeah.
Alright,